In this lecture, we will talk about maximum power transfer. First of all, I will give you a definition how we can find the maximum power transfer function. Then we give examples and exercises. So, maximum power transfer. Some circuits require maximum power delivery to load, resistance, or whatever you connect right there. To find the maximum power transfer, we need or we can represent this circuit as Thevenin equivalent circuit. So we can find the equivalent voltage source, equivalent series resistance value. Then we can find out what is the loading resistance value to have maximum power transfer. When I look at here, the power, if you have an equivalent circuit here, Thevenin equivalent circuit, when we find the power, PL should be equal I times VL, right? VL. And I times VL will be equal again I times RL. That's why we have I squared times RL here. We call PL right there. So that's why we have I squared RL here. When we look at the I, how we can find the I? If I look at the circuit here, this is the our I right there. I should be equal VTH divided by RTH plus RL. So we apply this one to right there our equation, PL equation comes right there, VTH square divided by RTH plus RL square times RL. Now we can actually, if you plot this one, PL function of RL, somewhere it's gonna go to maximize. So this is maybe RL. If you call PL right, it's gonna go up and down. To find the maximum value, we can take derivation of this one here as a function of RL. So we can see what is the maximum, what is the RL value that power goes to maximum right there. So we have this one here. So we're gonna have dPL divided by dRL will be equal. VTH is constant. I'm gonna put that one outside here. VTH square d over dRL will be this one here. So we have here RL divided by RTH plus RL square. Let me change the color here. So derivation will be here. VTH squared, parentheses, you're going to have first numerator derivation will be 1. So times RTH plus RL square negative. Second part derivation will be here 2 times RL is there, RL times 2 times RTH plus RL right there. Okay, divide by will be here RTH plus RL square is gonna be 4 right there. So when I look at this function, to find this function equals 0 here, to find the peak value right there, assume we have VTH value. So we need to say only this, let me go to draw part right there. Only if this term is equal 0, that will be equal 0 right there. So basically we can say here, this way here, RTH plus RL square minus 2RL RTH plus RL should be equal 0. So from here we can say RTH plus RL square will be equal negative 2RL RTH plus RL. So this will cancel this one here. So from here you will see that RL will be equal RTH. So what's that mean? If it means the load resistance value equal to uh, the equivalent RTH value, that we can have maximum power transfer. So P max will be equal here I squared times RL, which is equal here RTH basically too. So I squared times RTH basically here. What is I? In this case, if RL equal RTH, because of this term right there, it's gonna be here VTH divided by 2 RTH times square here, but not this one here, square right there. Let me erase the other one here. Okay, so times RTH, so this will be here VTH squared divided by 4 times RTH P max. Let's give example, see how we can find out to here. So first example here, we're gonna find the RL value so we can have maximum power transfer to this RL right there. So we'll take this part here, find the equivalent Thevenin equivalent circuit here. First, if you find the RTH, we'll take the independent sources out off. That means this will be short, this will be open here. That's why we have short, we have open here. When you look at from this side to RTH, you will see 120 parallel to 240. So 120 parallel to 240. Then you're gonna have some plus there, plus 60 plus 40 right there. The total will be equal here, I believe 180 ohms right there. So this part right there, find the RTH. So to find VTH, we're gonna put the sources back. We're gonna see how much voltage we have here, VTH. Basically same VTH equal VB here, VB. How we can find the VB? If you write node equation, you can find it too also. And we know the current right there, we can find how much voltage drop right there, then can find VB. In this case here, we said, okay, we're gonna write there the node equation right there. If I call this one is I1, this one is I2, this one is I3 here, I can say I1 minus I2 minus I3 equals 0. And you know I3 is also I3 is equal negative 0.2. We can put that one right there too also same time. So I1 will be equal here. I1 is 24 minus VA divided by 120. Negative I2 will be equal VA divided by 240 minus plus 0.2 here. From here we can find VA easily here. If you find VA from here, it's coming here, VA is 32 volts. To find VB, we know that we can write VB as like this. We can write I3 is like this too also. We can say VA minus VI2. We can write VA I3, I'm sorry. Let me make correction right there. One more time. We can write I3 as like this. VA minus VB divided by 60, which is equal negative 0.2. We know that VA value 32 minus VB divided by 60 equal negative 0.2. VB comes from here 44 volts. 44 volts. So our circuit will be like this. We're gonna have 44 volts Thevenin equivalent voltage source and 180 ohms RTH serial right there. So this is RL here. So if you want to have maximum power transfer to RL, that means RL should be equal RTH, which is equal 180. So from here we can find the power easily because we know the voltage right there. We know how much it's gonna drop right there. We have an exercise question here. First exercise question is this one here, and when we look at this one here, this is our RL. This is our RL. So we're gonna see how we can have maximum power transfer to RL. First of all, let's try to find VTH. To find VTH, because we're gonna find the Thevenin equivalent VTH. We're gonna take off the RL, so we have this one here circuit plus minus here 40. We're gonna have this one here. We're gonna have this right there, this way here 3 VX, and we will have this one is here 50 ohms, and this is empty right there. We have also here output right there, another resistor right there, we have it, and we have also this resistor right there. This is the A, this is the B, this is 60 ohms, this is 150, this is 50 ohms. So this is plus minus Vx. There is no current goes here, so I can say Vx equals 0. If Vx equals 0 here, I look at this way here, that means this is equal 0 right there, so nothing goes right there. So my circuit, simple circuit, we have here only this part here. We have this part right there. So if I know the voltage right there, same voltage will be right there. So VTH, which is equal plus minus right there, VTH will be equal here 150 voltage division, 50 plus 150 times 40, that will give you 30 volts. To find, let me see, I have enough room right there. To find RTH, we're gonna take off the voltage source. We're gonna leave the dependent source right there. Only take out the independent voltage source. We're gonna put 1 volts, include 1 volt is in RL AB connection right there. So we're gonna have short circuit right there. We're gonna have this one here. We're gonna have this one here back. So we have this one here. We have this one here. So we're gonna put right there as 1 voltage source out of the 1 volts, and we have still this current right there, connect right there. Let me put the values here. This is 60 ohms. This is plus minus Vx right there. This is 50 ohms. This is 150. This is 50. This is 3 Vx. Actually, I see this one parallel to this one. Let me simplify this one here. So I'm gonna have here one resistor. I'm gonna have another resistor right there. I'm gonna have another resistor right there, and this is my voltage source right there, and this is 50 ohms, this is 60, this is plus minus Vx, this is I think parallel 150 parallel to 50, I believe coming there 37 point ohms. So we have still this one right there. This is 3 Vx. Okay. I can find first what is Vx equal. If I wanna select current like this, I'm gonna select this way here, if you don't mind. Undo. Let me change the color here, color green. I'm gonna select my current goes this way here, I. Okay. So my Vx will be equal 60 times I. Okay. So I'm gonna look at the mesh equation, this one here. I can write this one as like this. Start from right there. I will say negative 1 plus 50. I will say I1 minus, is it minus or plus? Let me see, plus 3Vx plus 3.7, no, 37. Undo. One more undo here. 37.5 I want to delete this. I use I there, so I don't want to use messed up right there. I plus 60 I equal 0. So let me do this one like this. 50 I plus 3 times 60 I plus 37.5 I plus 60 I will be equal 1. So when I combine all this I right there together, I will have 327.5 I will be equal 1. Then I will be equal 3.1 milliampere. So RTH actually is this. Then from here, RTH will be here 1 volts divided by 3.1 milliampere. This is coming here 327.5 ohms. So we can represent our circuit as one voltage source. I'm negative right there. One serial resistor, and this is our RL. So this is here 327.5 ohms. This is here, we have this one, we found it as at the beginning VTH 30 volts. So that means RL should be equal RTH. That means equal 327.5 ohms. I have one more question here, exercise question. And this question looks interesting, but it's not complicated, but let me see how we can do this one here. Again, we're trying to find out from here what should be RL right there, value. Okay. I think I will do this one like this here. Let me see how I can do this one here. First of all, What is V0 right there? Uh, because if we're gonna find VTH, RL is not there. We're gonna look at this way here. Find V0 first. V0 will be equal to 2K divided by 2K plus 3K times 4 volts, which is equal here, I believe, 2.4 volts. So I look at here, this one and this range right there. If I call this one as V1, V1 will be equal negative 100 times 2.4, which is equal negative 240 volts, right? If I look at the V AB or equal, which is VTH, that will be equal here 50K divided by 10K plus 50K times 2.4. That is equal, I believe, negative 200 volts. Okay, how are we gonna find the RTH? Again, in this case, what we have? We have dependent source. So to find RTH, we're gonna make short circuit right there. We're gonna have this one here, resistor right there. We're gonna have this resistor right there. This is 2K. This is 3K. This plus V0 here. And when you come right there, you're gonna have 100 volts. And we have this one right there. We have here what? 50K. I'll put there 1 voltage source, 1 volts. I'm gonna try to find this I0 right there. When we look at here, V0 will be equal 0 volts. That means I'm gonna change the color right there. That means plus minus here, or it's gonna be 0 volts. Okay, it means short, right? So our circuit will be like this. Our circuit will be like this here. We have here what? 10K. We have here 50K. We have 1 volts. So this I0 here, this I0 will be equal here 1 volts divided by 10 parallel to 50, 10K parallel to 50K, or our RTH will be equal 10 parallel to 50, 10K parallel to 50K. That's the answer. We have it. 10 times, which is equal 10K times 50K divided by 60K right there. So final answer we have here voltage source plus minus. We have a resistor right there. We have, this is the one, RTH equal here. This is RTH. This is equal VTH, which is equal negative. This is negative. I can put there negative 200 volts. This is the final answer. Or we can change the rotation right there.